So Sean seems to be in the online meeting, so it might just be the two of you today.
Yeah.
Oh, did you know that it's going to happen?
Yeah, it's my roommate.
Oh, I didn't realize that. Okay. So he chose to stay home today?
Yeah.
Cool.
I think maybe because their faculty is online today.
Ah, that makes sense. Cool. So we have 2, 3, 4, 5, 6, 7. So we're missing one person. Don't know who. You think with this small group of people, I would know who's missing.
I think everybody that's usually online is here.
Oh, we're all here. I can't count. Apparently, my ability to do simple, like, second grade finger counting to 8 has failed me entirely. It's not even like it's a hard counting problem. It's 8. He says,
Maybe start at the 0 index.
Maybe, who knows? Maybe I got all computer sciencey and started at 0. I want to talk about the gender article that we didn't get to on Monday. Before I do that, though, I want to talk about some things for Friday so that we're all on the same page there. And let me actually share my perusal. Actually, I guess it would be this. Share my web thing, and then that'll go to the perusal tab. So there should be now several new, oh, I should actually remove this guy because this is not gonna work. That's still there? Oh no, that one does work. Ah, yes. Okay, there's another one that behaves weirdly that we'll talk about. So there's several things to read for Friday. They're all really short. Don't freak out that it's like I've dropped 8,000 pages of writing on you. These are short blog posts and things like that. This is the sort of stuff, that you regularly read while you're eating breakfast and things like that. So I don't think this will be a huge deal. There's the bad smells in code. That is the chapter. I guess it would help those of you that are here if I lower the screen, wouldn't it? Momentary pause for everybody else while we wait for the screen to come down. So this is chapter 3 from Fowler's book, Refactoring. So the library got it sorted out, and then I just cheated and put it on perusal because I think that's worked pretty well. I've enjoyed seeing sort of the annotations and the commentary. I think that's been helpful. So this is 14 pages long. So it's not a big, long, complicated thing. It is a little technical in places because he is talking about how what isn't good about software, and in particular object-oriented software. So it assumes that you know, that you understand, that you remember some things about objects and the way object-oriented programming works. And I realized that when he wrote this in 2004, and when I first used this in a class probably 15 years ago, something like that, we wrote a lot more Java code than we do now in our program. In our program, we use a lot of different languages now that have, some are more or less object-oriented. So as you read this, if there are places where you're like, not sure I understand what this is saying, or what this would mean in practice, like that's a great question to ask. And I'm here to try to help clarify some things like that. So, do you understand the smell? In what way is the smell bad in terms of code quality, since this is a course on code quality? Have you ever encountered it? Either because, you just ran across it, or you actually wrote code that generated that smell, and maybe you knew it at the time and you just pinched your nose and moved on, or maybe you didn't really appreciate at the time that you were making a slight stink for everybody else, because you were new at things and you were still learning stuff. How would you document that smell? How would you explain or convince other people that this was a thing, it existed in the code, and it was a problem, right? Because if you're going to get the team to take something seriously, you've got to be able to explain it to them. And that's not always trivial. And so one of the questions I want us to be thinking about all semester is, how do we communicate effectively about code quality? Because if we're going to work in teams to make high quality code, we've got to be able to have a conversation about it. We've got to have some language that talks about what does that mean and why do we care and how do we get there, okay? All of those things are important. And then sort of the obvious one, how do you make it less stinky? What do you do that could make it better downstream? Okay, so there's those, there's that reading. Then there are three short pieces. Why refactoring is a must, is a, I guess I don't give you a little preview or anything of that one. Let's see, I think I have, not that one. Readings on refactoring. So why refactoring is a must is a short blog post arguing that you absolutely, that's the whole thing, like down to any questions. That's the entire piece. So it's not long. But he's making the case that if you're going to be doing agile, you've got to refactor. As he says, sorry, not optional, necessary. So he's taking a pretty strong position. And so I think that that's important to sort of hear that voice in this conversation. Then there's refactoring not on the backlog. This is by the same guy, Ron Jeffries. And he's essentially arguing that you shouldn't be putting refactoring on, if you think about the ZenHub list, there shouldn't be stories on the ZenHub list that are refactor stuff. That it should be part of what we do from a day-to-day basis, not a thing we can do or not do, put off, sell to the customer, not sell to the customer. And so it's also a short piece, more pictures than words. And then I think the bottom is right there. So it's not a long piece, but I think it's very nice. This branch by abstraction describes a particular kind of refactoring. And we can talk about this more maybe Friday if people have questions about it. But I think that he's essentially, you have the situation here where you have what he calls a flawed supplier. There is a piece of the code that you just don't like. It's an old piece of legacy code. It's just a stinky, badly written piece of code, whatever, right? It's a thing that causes you trouble in your life. But you have client code that uses it. There are pieces of your code that depend on this thing. And so what do you do about that? And he proposes a technique, an approach for addressing that. And part of the reason I want to bring this up is, A, it relates to some questions that came up, I think, on Monday, today's Wednesday. But also, when we get to the nasty data structures code that I've mentioned, I think there are parts of that code that could be seen as a flawed supplier in a useful way, and that students often get stuck on the problem of, well, everything depends on this decision, and this decision stinks, but I don't know how to fix it because everything's dependent on it. How do I get out of that trap where I can make the flawed supplier better without breaking all of the clients at the same time. And this piece by Fowler talks about how you can do that, a way to do that. And I think it's actually quite nice. So I recommend reading that. And then there's one last thing, this workflows of refactoring. This is not in Perusal because Perusal and it don't like each other. Because what Fowler's done here is created a little slide deck, and Perusal, so there's, and I assume this is using JavaScript or something, so you could, it's only 13 slides, there's very little text, but Perusal, when you give it a web page, it just takes a snapshot of the page and incorporates that into Perusal. That's the thing you get to read. So if I put this in Perusal, all you ever see is slide 1. And it's no longer a dynamic thing, like all the JavaScript doesn't happen or gets turned off, or I don't know what exactly they do, but it doesn't work. So this one isn't in Perusal, it's just, yeah, you should go have a look at it. There's some nice ways of thinking about different approaches to refactoring in that. Again, it's not a lot of text. So, so quite a few readings, but in total, you know, it's a lot less work than reading a chapter of Thucydides or, you know, a page of Hegel. So there are worse things in life. And I think actually all these people write well and have interesting things to say. So questions about any of that stuff? Anybody online? Got a question, comment? Okay, looks like we're good. So I want to talk about the gender thing. Women considered better coders, but only if they hide their gender. And I want to start by actually asking a couple of questions. There we go. All comments. Oh no, not all, not that. Open. There we go. So Joe shared links to a couple of things, and I wanted to actually follow up on a few of those and ask a couple of questions. So is this visible at home? Are we good with this big table? So so Joe, how did you find this, just out of curiosity?
I think I researched something about like women coders over time or something like that.
Okay. So he said he thinks he searched for something like female coders over time or women coders over time or something like that, and stumbled into this National Center for Education Statistics table. And to be fair, I've never seen this table. I've seen data very similar to this in other places. There's an organization called, man, I was actually thinking about it as I walked to class, and now it's totally left my head. It'll probably occur to me in a little bit, but there's an organization that does annual sort of surveys of the state of the field and writes these sort of quite detailed and useful reports, which we use a lot in the discipline, for example, to make our case for why that would give us another faculty position, not that you care, but that includes a lot of gender breakdown data. So I've seen sort of data like this before. My glasses and my mask are hating me. But I think it's certainly really interesting to see that, you know, in the late 70s and early well, even late 80s, the percentage of women in computing with bachelor's degrees, and as Joe points out in his comment, degrees and jobs aren't the same thing, right? But I think that jobs, they're almost certainly correlated strongly, right? And we can get into sort of issues of in what ways are they not correlated. But assuming that for the moment they're reasonably correlated, you're seeing a lot of people in the 80s, a lot of women in the late 70s and 80s getting computer science degrees. We're up into the mid 30%, high 30%, which is still substantially less than 50%, right? So we're not at parity, but we're, you know, not like completely off the mark. And the trend line from the early 70s to let's say the mid 80s looks pretty good. Like if all you had was the data from the early 70s to the mid 80s, you might think we're, you know, on track for good stuff. We will hopefully, you know, hit something close to parity, you know, in the next decade, and then we can all like have a party and cake and be happy. And yet, in fact, it goes the opposite direction. It turns around, and in 2010, the numbers are down to 17, 18%, which puts us back in sort of the early mid 70s range. And that's like, oh, that didn't work out well. Now, Joe, you said something in the comment about having read something about the introduction of PCs being relevant to this. Can you do a short version of what the case was there? Or, and if you're like, I don't really remember it that well, that would be fine too, but I'm curious. Yeah, so you're talking about this part that they were marketed to boys and that had a significant impact down the road.
I'm not sure if that would have like an impact or if that, because that seems like it would be like delayed about like.
Well, okay, so this is interesting, and it actually, my life experience sort of lines up with this in an interesting way. So I graduated from high school in 1981. I'm old, just sign me up. And so I was in high school sort of in this period of time, and finished high school sort of right around here. The very first widely available personal computers were happening around then. So when I was in high school, my parents got a Radio Shack TRS-80, well, and it was just the Radio Shack TRS-80. There weren't even models then. It was later kind of renamed the Model 1 when they came out with the Model 2. And we had it had two flavors, and we had the upgraded version that had 16K of RAM. Kilobytes of RAM, 16 kilobytes of RAM, and level 2 basic, which means there was basically more ROM, and there was some additional basic instructions that the interpreter knew because they had more read-only memory that they had put that information in. So we had the fancy one. And the competitor, the only real competitor at the time was the Apple II. And my parents actually spent a lot of time debating whether to get a Radio Shack or an Apple II. And in the end, so I had an uncle that worked as a software developer at JPL in Southern California, and I talked to him a lot. And in the end, the decision was to get the Radio Shack because we had a Radio Shack in town, and the nearest Apple anything was hundreds of miles away. And so the assumption was if there was a problem, if there was a local dealer, they might be able to help us out. So there was really just those two computers. And when I graduated in 1981, I think, and you know, this is in a sort of a semi-rural town of 100,000 people in North Texas. So we're not talking Manhattan or San Francisco. But in my high school, amongst my friends, I think I was the only person that had a computer at home when I graduated from high school in 1981. So they were still really quite rare at that point. That said, it did really affect me. I learned to program on that. It had been in the house, right? I had been able to teach myself to program. I was lucky, I've got so much privilege, it just comes out my ears. But I was lucky I had an uncle who worked in the area who was able to help me out with some things. My parents were willing to buy this device, which wasn't cheap. I don't remember the price, but wasn't inexpensive. And they didn't really understand it. Neither of my parents were programmers, but they sort of got that computers were gonna matter, that this was a thing, and that I liked it and I was good at it. And my uncle was able to help them out and blah, 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 blah. So I get a computer. So I graduate from high school knowing how to program. I actually had worked a summer as a programmer for my dad because nepotism, right? But my dad was able to hire me to write software for his manufacturing firm. So I'd had that level of experience when I got out of high school. And I was the only person in my high school that had anything like that when I graduated in '81. I think there were people at, in bigger cities, at schools that had sort of better connections and more equipment that had experiences more like that. But for me, I was the only person that was in that situation. So I don't think that I don't think there were enough houses with PCs in '81 to have really made a big difference yet. But by the mid '80s, late '80s, they were becoming a lot more prevalent. And you did see a lot of advertising. There's actually a video somewhere, I'll have to see if I can find it, that speaks directly to this question and has some really great, in a inverted comma, quotes, great video, still advertising images, and actually some clips of TV ads for some of these early devices when there was enough money at stake that people had begun to buy ads. And it's very much like you're buying these so that the 16-year-old boy can learn how to do programming. And they're very strongly aimed at young boys and high school age boys, and not at girls. And I think, how that affected families, I don't really know. I mean, it's hard to, advertising is a difficult thing to tease out the impact of advertising. But I could certainly imagine that it was part of why things changed. Whether you could just blame it entirely on that, complicated. But I certainly could imagine that it's part of what happened there. You look like you were going to say something, Joe.
Another thing that is interesting there in like the mid-80s, the total number of people with computer science degrees going down as well. So like that for all of them.
Oh, you're right. So it peaks at like 42,000 in 1985 and then drops down substantially. Well, that's really interesting. And then it doesn't come back up to over 40,000 again until 2000. Wow.
That's really weird. I would think having personal computers at home, if anything, would allow people more access, or at least people who it's marketed towards.
Yeah. So Utkarsh, I assume you two can't really hear what's coming out of the speaker here. Okay, so Utkarsh was saying, he would have expected personal computers at home would have opened more doors and you would have seen an increase, which I assume was part of your comment, Joe, is that it seemed like that seemed surprising to you that it went down there. And that's really interesting. And I don't know that I have anything clever to say on that. I don't know that I've seen anybody analyze that data and say something about why that might have been the case. I mean, and this is totally speculation, so ignore it. One possibility is maybe you had an increase in people taking jobs without getting degrees. When there's been high demand for software developers and people have been able to self-teach effectively, a lot of times people don't have degrees. So Steve Jobs never got a degree in computer science. Bill Gates never got a degree in computer science. And you get these people that left school and went and did work, and they're kind of, you know, big names, but they're in this time period, right? Steve Jobs dropped out in the mid to late 70s. Bill Gates would be around the same time period. And so if there were a lot of jobs and you didn't need to have a degree because, you know, you were competent and there were more jobs than people with degrees anyway, maybe people were just leaving school or never starting school. Utkarsh, you were going to say something.
I just found something from Stanford about how it's not the interest of a student, but rather the department's ability to. Well, actually, I just found it, so I can't even summarize it.
You haven't had a chance to look at it carefully yet,
Yeah.
but it might be relevant. And I know Stanford has thought a lot about the gender imbalance in their computer science program. They did some very cool early work on some of these questions. When people I think in the 2000s, people started to realize that the situation had gotten really very bad, and that we needed to be doing something about it. You know, we had gone, you know, it went down kind of slowly in the 80s, but by the 2000s, it was pretty clear that we were in a sustained way lower than we had hoped to be, and that some people started to be interested. And then, of course, you know, the situation got worse and not better, which is unfortunate. Here at UMM, we have had an interesting experience that we've never really been able to deal with in a way that I think has been effective. So I came here in 91 as a faculty member, and until 99, Morris was under quarters, not semesters. So we had 3 academic quarters plus summer, hence the quarters, you know, thing. And so we started fall quarter in late September, and they were 10-week quarters, and classes met 5 days a week. And fall quarter ran from late September to December, similar time frame to a normal Morris semester. And then winter quarter was like single digit January, like early January to spring break. And then spring quarter was spring break to early June. So graduation was like second or third week of June. And under quarters, the general education requirements under quarters included a computer science requirement. Every student at Morris had to take a computer science class. And there were 2 options. One was basically the intro programming course for the major that would be somewhat like 1301 or 1201. They were a little different, but it was, oh no, I backed that up. So that was true when I came in 91, but we switched to what was called a CS0 course, which was more a general introduction to the field. You actually learned a little bit about Turing machines. You did a little bit of programming. It was actually a neat course. That was the first course KK took when she was a student here. And so that was one option. And then the other option was really for people who knew nothing about computers and had no interest in learning very much about computers. And it was sort of half applications, like literally how to use email. Because in 1992, most people had never seen email until they came to college. Later on, how do you use the web? Like, ooh, this web thing shows up in 1995. We'll give people college credit for learning how to use the web. Yeah, it was a strange times. And a little bit of spreadsheets. And then basically 1091, the ethical and social implications class. About half of that requirement course was that. And so everybody took one of those 2 courses. to graduate at UMM. When we switched to semesters in 1999, the campus chose to drop that requirement. They felt that Minnesota high schools were requiring computing as part of the curriculum in the state, and that we didn't need to be doing it anymore. That this had become kind of normal enough that it didn't need to be a college level thing. It could be handled earlier than that. And, you know, the computer science faculty were like, yeah, we're not entirely convinced, but it wasn't, we didn't have a great argument to the contrary, to be honest with you. And so it happened, the change happened. And then it took a few years for us to realize one of the implications of that. You don't see this stuff right away. But one of the things that we noticed then was that the percentage of women and underrepresented groups in our program went down pretty sharply. And I think, right, and unfortunately we weren't collecting good data at the time, both before and after, which is what you would have needed to have a really comprehensive study. But I think that one of the things that was happening is if you talk to computer science majors now, and this was true 15 years ago also, almost all of our computer science majors came to UMM expecting to major in computer science. So I'm curious, is there anyone of the 8 of you that did not expect to major in computer science when you came to UMM? Anybody? I think the answer is no. So there doesn't seem to be anyone who didn't. Oh, Austin? Right. Actually, why don't you unmute your speaker and I will.
So when I went to my first school, which was UW South, I didn't quite know what I was going to major in. I was debating a few majors. I took a programming course, and that's what introduced me into it. But when I transferred here, I was already a computer science major.
Cool. So, but in some ways, it's a similar story in that okay, it's a similar story to a story I haven't told. So that didn't really work very well as a transition. It worked great in my head. It just didn't work very well in real life. In the quarters era, when everybody was required to take computer science, most students took the computer science class in their first 2 years. It was kind of like college writing. You were encouraged to do it early. I mean, actually, WLA, you're kind of required to do it your first year. And it wasn't required to do this your first year or anything, but a lot of people took it in their first 2 years. And so there were a lot of people that took it and went, oh, I kind of like computer science. I'll do a little more, and then a little more. And then they find themselves majoring in it, sort of like what Austin's story was. And that was actually KK's story. KK came here as a French major and took computer science as just a gen ed requirement. Liked the course, took another one, liked it, took another one, ended up double majoring in French and computer science, going to grad school in computer science, and now she's a faculty here in computer science. But that was not her intention when she came. And now that we don't require that everybody take a computer science course, I think we're getting a lot fewer what I would call walk-ons, people that came not expecting to do computer science, but got some exposure to it, liked it, and then joined. And that those people are much more likely to be non-white dudes like most of us, okay? Those are more likely to be women, people of color, you know, other groups that are not well represented in the field. And so you look around the room, virtually or physically, in computer science classes at UMM, and it's a lot of dudes, and it's a lot of white dudes. realistically. And, you know, you can write off part of the white dude part of it to the demographics of the state of Minnesota, which is a fairly white heavy state. But it certainly doesn't match the demographics of the campus, where easily more than 10% of the student body are people of color. I think it's probably closer to 20 or something. And we certainly do not have, you know, those sort of numbers in the computer science program. And certainly when it comes to gender, you know, over half the students at UMM are identified as female, and that is not true in any computer science class I've taught in a long time, if ever. We are more than 50% female in the faculty, which is actually super rare, and it's always fun to be able to say that at, you know, conferences. But you know, we're not doing great on the number of women. And I don't know quite what we do about it, other than convincing the campus there ought to be a computing requirement. But it's a little hard to convince the campus there ought to be a computing requirement just so that we can have more women in our major. The politics of that are complicated and not super exciting. So yeah, I don't know what we do about that. So, but clearly it made a difference. Like that decision to drop that requirement made a huge difference in our program. And that difference has persisted through to today. I've talked a lot. Comments, questions?
I was just wondering, isn't it that math majors have to take a programming course here at Moritz?
Yeah, so I think the question from Utkarsh is, do math majors have to take a programming course? And I'll look at my resident double major in math, and I think the answer is yes. Okay. Yeah, so I think both math and statistics require an intro programming course, but you're flexible on which one? 12 or 1300, 1301, I mean, yeah.
Yeah.
Only other major that I know of that requires computing, management has a quasi requirement. It's one of these things where you have to take one of three things and you get to choose which one. And one of them is a non-majors computer science course that we created sort of in conjunction with them, 1251, data management manipulation. And that has a large number of management majors in it as a consequence. But I don't know that anybody else requires computer science at UMM. Go ahead.
Sorry, I didn't jump in. I was just wondering because I do know it also depends, like, I think when they're required or when someone, like you said before, if they're introduced in high school, there's a great chance. I do have a female friend who's a math major, who she has been talking about, you know, should I take 12-1 or 13-1 for multiple semesters and kind of, you know, juggling around like where it would go with the rest of her schedule.
Yeah.
And I think she'll take it sometime this year. Well, she'll have to, she's graduating. But but I was just thinking, like, as a senior, I mean, could be that you take a programming course and you could be like, man, this is really cool. And maybe I'll explore in my own time or something. But the chances are you're gonna be like, well, I'm about to be out of here. Like, you know,
Right.
this there. So.
And that's a real issue. So to repeat a little bit, you know, part of it is when you take it. And so, of course, she's got a friend who's likely to be taking a computer science class their senior year. But by then, even if they love it, like, what are they going to do about it? And I taught 1301 this semester last year. And so I had 30-something students in there. And, you know, when you're doing an intro class, you're always on the lookout for people that are doing well, but don't seem to be, you know, computer science majors, at least that you're aware of, and be like, hey, you know, you're good at this. If you wanted to do more computer science, like, I think you would be good for this. And in particular, I try to encourage underrepresented groups, if possible. But I try to encourage anybody who I think is decent at it. There were several women in that class that did really, really well. And it turned out they were all juniors or seniors. and they were mostly math and statistics majors, or math or statistics majors. And I'd talk to them and I'd be like, man, you're really good at this. Have you thought about taking some more computer science? And they'd be like, yeah, except for I graduate in a few months, and no. And I'd be like, oh, so sad. And if they had taken the course a year earlier, a minor might have been possible. If they'd taken it 2 years earlier, a major might have been possible. Not that everybody needs to major in computer science. I'm not trying to say that. But when you have a field that, you know, the job market's good and the pay is high, you know, people, you'd like to hope that people are at least aware of it as a possibility. And I don't think we do a great job in the current universe of always bringing people in. And Utkar's your story lines up perfectly with, you know, my experience in a number of situations as well.
I have a question.
Yes.
There's a requirement for a science with a lab, correct?
Yes.
And are any of the CSci classes, do they count for that?
No. So the question from Jacob is, do any computer science classes count as science with a lab? And no, the computer science got put, better or worse, in the mathematics and symbolic reasoning box. And the science and science with a lab, that was meant to not include math, statistics, and computer science. That's like bench science lab, not what we call lab. And you could debate that. I mean, my personal thought is that our labs in a class like practicum or software design are actually a lot more like a studio experience in art or being like in the choir than they are like doing chemistry in a lot of ways. And so I think we would have a hard time making the case that practicum should be science with a lab. I think that the science, so, okay, and nobody heard this from me, this never happened, but you know, you're smart. If you look at the requirements, the gen ed requirements, it's pretty clear that one of the purposes they serve is to ensure that majors have students and can justify their existence and not lose their staff, right? There are things like the fine art requirement, which is satisfied almost entirely by one discipline, that would have very few students take its courses if it were not for that requirement. This is not an accident. You can do the math. And so, you know, the science and science with lab requirements, yeah. Utkar's like, watch out, Nick, it's recording. Actually, I'd say this in front of anybody. I have said these things in front of the chancellor and the dean. So, you know, it's not, and the door is open. People, if anybody walked by, they'd hear the whole thing. But, you know, I think there are gen ed requirements that are there for good pedagogical reasons. And I think there are gen ed requirements that exist, at least in part, for strategic financial reasons. And if that's, you know, I am not here to defend that. I don't think those are good reasons to be making those choices, but I think that's, you know, the truth of it. And then the fact that the sciences and science with labs are in a very well-defined box that doesn't include us, and that we're in a very well-defined box that doesn't include them, is partly, frankly, to make sure everybody gets enough people and can stay in business. And so if we were to be like, well, practicum should be science with a lab, I don't think that would be very popular as a conversation starter at a curriculum committee meeting. Now, I'll be able to tell you more as the semester develops because I'm actually on curriculum committee for the first time in my life. And one of the things that we're discussing is general education and potential changes to the general education program. It's a long-term process, but we are talking about some stuff. So there could be some changes. I don't know. We'll see how this goes. And I've never been on this committee before. So I look forward to being grumpy and obnoxious in a quasi-public setting about things that I'm kind of grumpy and obnoxious about, frankly. So there you go. So yeah, that's a little backstory on dental education requirements. So does that answer your question, Jacob? Maybe more than you wanted, even. Okay. Okay, so there's a bunch of stuff. I had another question I wanted to pull up, but does anybody have any other comments or questions on this chart or that aspect of the article? Or actually, I should say, any questions or comments about any other part of the article that you particularly want to talk about?
I just wanted to add that the link, the article I found earlier by Stanford, I posted a link to it.
Yep.
And they have a nice graph as well as some sections about what they call a capacity collapse, kind of like as what they found for the reason for disciplining students.
And so when you say capacity class, what does that mean? I don't know.
According to this Stanford article, they're talking about how it was actually the university and colleges that were not able to satisfy the growing student demands.
Ah.
Yeah, they claim that students were actually way more interested after the introduction of PC and things, but they just didn't have like the resources. Yeah.
Ah. So this is actually very interesting and seems plausible to me. So I was at grad school at UT Austin, University of Texas at Austin, which is the big state school in Texas, like the University of Minnesota here, the University of Michigan, you know, one of these great big 40, 50,000 person institutions. So I was a grad student there from 86 till we moved here in 91. And their intro programming course was in Pascal and had hundreds of students. I mean, really large numbers. And I had friends that TA'd that class. So there were faculty who would lecture at, you know, great rooms full of people. And then TAs would have sort of discussion sections where basically students in smaller groups could come and ask for help and stuff like that. And I had friends who TA'd that class. I never TA'd it. But they were told explicitly that it would be a good thing if they could fail something like half of the students. And I'm not joking. I'm not making that number up. This is not Nick just exaggerating, which I do a lot. So I want to be real clear that this is not one of those moments. They were literally told that a 50% fail rate would be a fine and mighty thing because they did not have the capacity to move all those students through the pipeline. And so basically this intro class was in part a roadblock, a weed out course, if you want to think about it that way, to discourage a lot of these people from moving on because they did not have the resources to support hundreds and hundreds of undergraduates making it through the entire program.
And you say,
So Stout had similar sort of failure rates and
on the first year CSci, people in CSci classes, but it was whittled down very, very quickly.
so if the numbers whittled down at Stout, so for those who couldn't hear, Austin was saying that when he was at Stout before he came here, you had a lot of people enter the program and far fewer make it through. Were people leaving because they were like failing courses or because they just didn't like the program?
It was very mixed.
Okay.
A lot of people that just, and like my first class, the class ended a lot smaller than it began.
Oh, okay. So your first class had a significant drop rate over the course of the semester.
It was computer science 1, computer science 2.
Okay.
They were considered weed out courses. I knew some seniors and there's, so like the freshman class for the computer science program was large. But then with the senior class, it was dramatic. Not like, it was like dramatically smaller.
Interesting. So Austin's saying that at Stout, the numbers from the beginning to the end dropped dramatically. And we I think that most people that make it through data structures here go on to finish. We don't lose a lot of people after data structures. We lose one or two, but we don't lose a lot. It's a little, and not everybody goes to data structures from 1201 and 1301, but that's partly the intent. They're meant to be non-majors courses for people to find out if they like this or not. And we don't expect everybody to think this is awesome. It would be kind of weird if that turned out to be true. We would also have an enrollment issue to worry about. If all those people wanted to take data structures, we need more sections of data structures, but we consider that a good thing, not a bad thing. So I think Jacob was going to ask a question.
Oh yeah, it was just when you say resources, what do you mean? Like physical resources or like staff?
Mostly staff. That's the biggest problem at these programs. So the question was, when I say resources, what kind of resource do I mean? And it's usually a staff problem. That's almost always the limiting factor these days, is do you have enough faculty to teach the courses you want to be able to teach? And, in the Twin Cities campus, the number of computer science faculty is similar to the number of faculty in the science and math division here. They have about 40 faculty in computer science. And so, but I think they graduate more students proportionally than that would suggest. Partly because they have a lot of big classes. And there are things that we do, like software design, that I don't think they could do because they don't have the resources. And here I'm mostly talking faculty resources to provide that kind of experience for every computer science major. The closest thing they have to our software design class that I'm aware of is an elective where students apply to take the course and the faculty member lets in the people they think are good enough to take the class. So you're actually kind of hired onto the team, as opposed to, like, if you make it through data structures, we'll let you take software design. You do have to have a C or better, but if you can get through data structures, we'll let you take software design. And they just couldn't do that at a big campus. So thank you, Ukars, for the graph. I think that's really interesting. And I do suspect that was an issue. And if we look back at the table, and I've got too many things and I can't see anything anymore. The right-hand column are doctorate degrees. And notice that there's a significant lag between what might have been a boom in undergraduates in the 80s and 90s and a significant increase in people with PhDs doesn't happen until the 2000s. And so if you're looking to hire PhDs to teach computer science to help satisfy this increase in demand, you don't have the PhDs to do it. Maybe you're hiring people with master's degrees, but I suspect that lagged as well. And programs like hiring people with terminal degrees, like Morris advertises the fact that it's well over 90% of its faculty have terminal degrees. People get excited about that. So Ukars is saying in the chat that he took a C++ summer course on the Twin Cities campus and only got to talk to the TA help and TA for help. And that, I think, is very common at big schools because you've got so many undergraduates that would like to take a class, you don't have the faculty resources to support all that. And, I know here at Morris that we would like to hire more computer science faculty. I think the administration is sympathetic to that idea, but we're so freaking expensive that it's really a problem. Like, you could hire 3 college writing faculty for the price of a computer scientist, especially since what we really need is a systems person. And that's like one of the most expensive kinds of computer scientists in the universe. So a systems person would probably start at least 90K. And there are plenty of faculty on campus. I mean, people with several years of experience who are like in the 30s. And so the politics of hiring a systems person for us are complicated. And that unless you can convince like some alum to donate some crap load of money or get the state legislature to decide that, wow, we really want to support computing at UMM. And right now, with the economy being where it is, the legislature is not going to be doing anything like that. It's going to be very hard for us to get another person. We've been asking every year for years. And they're always like, yep, we get it. We think you're right. We're supportive, but we don't have the money. It's basically the short version. And so that's, yeah, a tricky problem. Sigh. And I think if we could offer more intro courses, then I think more people might take them earlier. I mean, part of the reason people take them late sometimes is they're just full and hard to get into. So if we offered more of them, people might take them earlier, and then we might have more people, you know, doing the major and a wider variety of people doing the major, but then we'd have staffing problems somewhere else, right? So it's a tricky problem. Sigh. Other comments, questions?
I was just wondering, we did talk about why there might be a difference in gender gap or other kind of gaps in representation in the computer science field, but I just wanted to kind of talk about instead of the why and how, kind of like what to do.
Yeah, right.
We kind of talked about that with recruitment, but I kind of one of my comments were about self-assessment because it reminded me of when we were talking about being honest about code. So like personally, I don't know if I don't know if I have shown previous bias. If I could, I would go around asking people, like, have I been biased towards you? I don't know. Were there moments where you noticed that or not? But maybe, I don't know, some kind of self-assessment thing on a yearly or some kind of basis where you can just assess, like, where does your decisions come from?
So you're proposing, if I'm understanding correctly, that maybe it would be useful if we were in a more systematic way doing self-assessment, both as for faculty and for students, having people think about in what ways you're possibly biased and how that's possibly affecting things. Is that sort of what you're suggesting?
No, I don't really have a formal system in mind. I was just kind of thinking like a self-improvement kind of thing people can do on their own.
Oh,
Maybe the systematic thing might help, but I was just thinking like maybe when looking at open source projects or codes or working in teams, just kind of being honest, like, am I judging this based on the code here? Or am I also taking things away from, I don't know, who a person might be? And my
Right.
bias, you know?
So sorry if I seemed a little distracted there. I was playing around with some things and I think you're coming out of the speakers now. Were you guys hearing bits of, was it understandable bits of Ukarsh or a little bit? So, and I don't know what I might have done to.
Should I just keep talking to save the change?
Oh yeah, sure, Ed. Go ahead and keep talking first.
All right, I'm a voice coming from everywhere around the room.
I don't know. I don't actually know. It says on my iPad, the selected device. Oh, actually, I know. It's probably this. So talking first.
All right. So maybe we could do self-assessments.
We can hear you really well, and there's not feedback. There's a weird echo when I talk.
Yeah.
Interesting. That's weird. Okay, but I can mute you. I can mute when I'm talking, and then I can unmute when you're talking, and then everybody can hear it. I think we may have accomplished a small thing today, and that's a win.
Awesome.
So I'm going to unmute you, Karsh, and you can try saying your thing again about what you're sort of envisioning as self-improvement.
Oh, I don't know if it could be what's the word? If it could be if we could make a program out of it, systematic or not. But I was thinking about how we discussed being honest before selling our technical what's the point? Futures and things. What can I really do? What can I accomplish in time? Just like that, being honest about, okay, when I'm looking at code, when I'm accepting pull requests, when I'm working with people, am I valuing their opinion? Am I like deciding I like this pull request code better than this? Or am I also, do I also have like bias towards based on who they are, what their name is, who I think they might be, stuff like that.
And I think that's important and a really good idea. I think the trick is, like, how do you tell? I mean, I think being aware when you're making a decision is important, but it's hard. Like, so when you're on a search committee, they give you the spiel about, you should not be biased in the way you read people's applications and all of that. And all of that's, great and important. But these issues can be very subtle sometimes. Let's take the pull request example. If I've got a pull request in front of me and the code's good, but the English around it isn't very well written, maybe because the person is a non-native English speaker, or maybe because the person just doesn't have great writing skills, but their code's really good. Like, how does that affect the way that I end up reviewing their pull request? It's hard to, not carry that baggage around. And if I'm used to a pull request that looks a certain way, and you submit something that looks different, just because you're not part of the culture that I'm used to, which turns out to be mostly white dudes, right? Then do you get treated differently because you just weren't part of the team and you didn't know the secret handshake, right? You didn't know that all the pull requests are supposed to do this and this and this. And you get that a lot online. Like, there can be people who get really pissy about, like, oh, your commit message didn't look exactly the way we wanted it to, and you didn't do the pull request exactly the way we wanted it to. And on the one hand, I'm sympathetic that, like, you want to having sort of a process and a mechanism can make things a lot less chaotic, but that can also be a way of keeping other people out of the club, because they never got taught the secret handshake somewhere. And so these things can be, I think, very difficult to understand. But I certainly think you're right, Utkarsh, that being self-aware and having the courage to say, maybe maybe this decision that I want to make is coming from the wrong place. And I need to be honest and aware of that, that can be important. So, okay, so we are like 1 minute away, and I had thought this would take not that long, and then I talked forever, so that blew up. I think there's a lot of other stuff in there, but I do, in the context of this class, I think actually Utkarsh really had the good last word, that if we're looking at code and trying to assess code quality, an important thing is thinking about, is what I'm thinking about the code, or is it about the person who wrote the code? And even when it's about the code, where is that possibly coming from? Is this person had fewer opportunities to be exposed to the secret handshake or whatever? And is there something of value here that just looks odd to me and I need to like deal? Or, is it fundamentally just not good in some sense that I can, but can I support that in some way other than go, ew, I don't like it? And I think that might be important. Okay, so I should shut up. We will meet again on Friday, and we will talk about refactoring, and then we will start next week in with the actual icky code, and there'll be some stuff where I'll put you in groups to talk about the ICKY code and come up with stuff. One thing that I think we might want to think about for next week is when we're actually doing sort of group discussion about code, would it be easier to just have everybody be at home and not even pretend to sort of be here so that everybody's in sort of the same place and it has the same sort of circumstances. And I don't have good ideas there. I'll maybe post a question on Slack about that. And maybe we can have some conversations about, are there kinds of things where it would make more sense to just like be at home some days and not bother trying to come in. And I'm hoping they'll get the microphones and stuff installed here so that we, because having Utkarsh's voice come out of the speakers was actually really nice. If we could get so that all the stuff worked, I think we could have a real discussion. It would be awesome. And I wouldn't just have to repeat things back and forth. So fingers crossed, we'll get that done soon. So, okay, questions quick in the minus whatever minutes were left. I can't even see the clock on the computer anymore. Minus 2 minutes that are remaining. I know some of you got crypto, so I should let you go do that. So cool, I'll talk to you all on Friday. Goodbye, go away.